We're going to look today at graphing inequalities where we have to do more than one step. So yesterday we were looking at where we were just either adding, subtracting, multiplying, or dividing, and remembering that if we had a negative, we needed to divide that, or we needed to flip our sign. So on our first one, I'm just going to rewrite my problem. 5x plus 2 is less than or equal to 17. We're going to pretty much treat this as if it was an equation with an equal sign. And the only time we change that is if we're going to divide by a negative number. So we can still draw our line down, and we need to get x by itself. So we're kind of going back to what we were doing at the beginning of this unit. The opposite of a plus 2 is minus 2. So the 5x comes down, equals 15. I wrote equals, but it's really a less than or equal to, so I should probably keep that in mind. I need to divide by 5. When I divide by 5, 5 is not a negative number, which means I'm going to keep that less than equal to, and that ends up being 3. So on my graph, I'm going to go to 3 and I'm going to put a solid dot. And then I need to test, is 5 less than or equal to 3 or negative 5? I like to test my endpoints, and it's negative 5. So that says all those points are the ones that are going to be working on this side. I should have been writing my justification in as I was doing that, but I subtracted 2 since positive 2 and negative 2 equals 0. And then we divide by 5 since that is the coefficient of our variable. So I'm just making sure I'm using a lot of my academic vocabulary here, my mathematical vocabulary, and sign does not flip. And it's because I divided by a positive. 3 solutions would be anything that would work. So in this case, x could equal negative 5, x could equal 0, x could equal 3. Anything that's in this range here where that line is would be considered something that would be a solution. I can use decimals. I can go beyond negative 5 to go lower. It just has to be a lot of different pieces to that. Let's look at number 3 here. So you'll do number 2 and check. Number 3, again, I'm going to start with just rewriting. And a lot of times it's helpful if we just want to step there. It's just called given, meaning that's what I was given to be solving. My first step is going to be to add 3. So add 3 to both sides. And our reasoning is to cancel out the negative 3. Because that's now going to make it equals to 0. And then we need to, I'm going to put a little dot here just to separate them. Divide by negative 2, since that's the coefficient of x. And when I divide by negative 2, I need to flip my signs because I'm dividing by a negative. So x is going to become greater than or equal to 1. So at 1, I put in a solid circle with a dot. And then if I look at it, is negative 5 greater than 1 or is 5 greater than 1? 5 is, so it's going to be this direction. And then x equals 1, x equals 2, x equals 4.5. All of those are going to be solutions that are true. There's hundreds and millions of solutions and actually an infinite number of solutions. You're just picking 3. Down here, we're working on just solving that inequality. So you're just doing the work that you did up in these boxes here. I'm going to do number 5 because that looks to be the hardest. And then, again, you're still expected to do all the other pieces just to help you out. I'm going to start with subtracting 1 from both sides. So 2 is less than x divided by 2. I need to multiply by 2 to undo that division. So if I multiply by 2 on both sides, it's not a negative, so my sign's going to stay the same. So 4 is less than x. This is where I stop. It doesn't have you graph them or give you any other solutions. You're done. You have a few more problems that you're doing, and then a couple statements. These are things that you might see later on formatives, summatives, so making sure that you actually understand those before you're turning that in.